Alright, so we're going to connect these two alternators in parallel. I've got both of them up and running. We're both at 210 volts, just because it's easier to hit than 208. We've got our running generator, which is generator 1 at 60 hertz, and we're going to parallel generator 2 to that. Now you'll notice that those 3 lamps at the top are flashing intermittently, and the synchronoscope is moving in the slow direction. So that means that generator 2, A, is running too slow, and B, has the incorrect phase sequence. So first off, let's just change the speed a little bit. Bring these closer to the same speed. So now our generators are running at just a slightly different speed, and you really see those bulbs kind of go through a pattern, right? They're never all the same at the same time. And the reason for that is we've got the incorrect phase sequence. So if we swap 2 leads on this incoming alternator, now you can see those bulbs are all changing at the exact same time. Okay, you see our synchronoscope there. If we change our hertz meter is sitting at 60, we change it to 60 to generator 2. Generator 2 is actually running too fast. So when we bring our hertz down, bring that second alternator down to 60 hertz. Now the lights are staying on. They're not very bright. They're fairly dim. You can see our synchronoscope needle is sitting here, and it's slowly dropping. So that shows us that we have the sequence right, because the bulbs are all the same, but they're slightly changing brightness, because even though they're in the same phase sequence, as the 2 phase positions move across each other, there becomes a potential difference between the 2 line A's, and then so right now they're 180 degrees out, and you'll see those lights dim when phase position's exactly the same. One. 60 hertz. Okay. So our 2 alternators are running almost the same speed. You can tell they're running almost the same speed because the rate that those lights brighten and darken is really slow, and this needle is just barely moving. Actually, it's kind of floating between one direction and the other, because these machines are not perfect. Our needle was basically stopped at 12. Oh, now it's moved off. If our needle is stopped at exactly 12 o'clock, all 3 lamps will be dark, which means there's no potential from one alternator to the other, and we can go ahead and close the switch and sync them. As we're falling out of sync. So we're going to let this rotate. We've got our incoming generator running slightly faster than the running one, and when they get to 12, are we not? Oh, flip this one on. I didn't have that one on, sorry. Now when they're close to 12, we're going to We've turned both generators on, so these two generators are locked in harmony. Okay? They're both putting out the same voltage. We've got watt meters, amp meters, and var meters. Now, if we happen to lose some prime mover speed on this alternator, you'll see our hertz is coming down just a little bit. Volts staying the same. Drop this a little more. Now you'll actually see the watt meter on this alternator start to rise, and this one's deflected in the opposite direction. That's because I've taken some prime mover power away from this alternator, and it's become a load for the existing one. So we'll bring these back up to 60 hertz because that's not what we want anyway. So now we're running at 60 hertz, still at our 210 volts. Everything's good. All right, let's put some load on this. Hope we have load. All those are off. Everything's good. We're going to close the switch to the load. We're going to add some resistive load, as well as some inductive load. So our voltages come down, our speeds also come down, right? So we're consuming power and we're consuming VARs. So in order to rectify that, we're going to have to increase our prime mover power. So we do that. Trying to bring this back up to 60 hertz, which we are. Now, alternator 1 has sped up a little bit more, and it's consuming 5 kilowatts. Alternator 2 is not consuming any. Alternator 2 wasn't brought up to speed fast enough. Okay? We're still a little low on the hertz, so we'll just put some more speed to that one. So now we've got the majority of the wattage pulling off generator 1 and a small amount pulling off the generator 2. I'm just going to pull this up. See our watt meters on generator 1 and generator 2. We've also got a kilovar meter on both, and they're sitting pretty close to the same. Now, if we want one alternator to take the VARs, we're going to increase the field excitation on one and decrease the field excitation on the other. This is where this is tricky because both hands got to be doing the opposite things at the same rate. Okay, so we've switched all of the, whoops, that didn't get quite enough. Our voltage has come down. Get it back to 200 volts. I've got this alternator carrying no VARs, and this one's carrying all the VARs that we're consuming in the system. So we've done that by over-exciting our field on this one. We're just over 1.5 amps. And under-exciting this field, which we're just under 1.5 amps. Now, if we want to move the VARs back onto this machine, we're going to do the exact opposite. All we're doing is changing the field excitation. Now we've got no kilobars provided by this one, all the kilobars provided by generator 1. So once they're up and running, you can have whichever alternator you want to be providing the majority of power. You can do that. Right now they're almost shared equally. this up totally to 0. So right now, generator 1 is carrying absolutely everything. No kilowatts, no kilobars. For one, the meters must be a little bit out of calibration. That machine's only drawing 0.2 amps. This machine, or the amount of current traveling through, or this machine's providing, is just under an amp. This one's only 0.2 amps. So the majority of the work's being done by generator 1. So if we want to shut generator 2 down to service it or whatever, we can, because there's nothing going on with it. Now you'll see this one must have been acting a little bit as a load, because as soon as I disconnected it, our speeds went out of whack. And our hertz came up. So hopefully that'll show you how you can determine if our alternators are ready to connect together, and how to shift the load from one to the other.